Alright, g'day everyone. Next up is the second application for differentiation that we want to look at. And that's all about finding the maxima or the minima of functions. So here's a parabola with the function of x squared minus x minus 2. Now you probably remember that it's pretty easy to find the x-intercepts. All you've got to do, well, there's two ways. You can either factorize this thing, which is pretty easy for this particular case, because you'll get, let me just write it over here, you'll get an x minus 2 and an x plus 1, and so from that you can tell that the x-intercepts are going to be 2 and minus 1, which they are over here. Now, so that's pretty easy. Your alternative to find the x-axis intercepts is using the quadratic formula, which is the x-axis intercepts are minus b, where b is whatever's in front of here, so in this case minus 1, plus or minus the square root of b squared minus 4ac over 2a. Okay, and this will always get you the x-axis intercepts for any quadratic. Okay, so using this formula, you can quite easily get these two x-axis intercepts. Now I won't do that for you. You can go back and look at quadratic equations and the quadratic formula in particular if you've forgotten. Now the hardest bit actually about sketching this function is actually the turning point, which is roughly here. Whoops, roughly there. Now we can't see exactly what it is just by reading off this graph, so we need to figure it out. Now the method you've already used in the past is to use completing the square. Okay, no doubt the words completing the square brings up very fond memories for you. So luckily this video is going to explain to you a different method, an easier method for finding the turning point, much easier than completing the square, much easier to remember as well. And it's using differentiation. So let's have a think about what the derivative means again. This derivative function f dash of x, which remember you can also write as dy dx, or if you want to, we can write it as df of x dx. So lots of different ways we can write it, just to jog your memory. Okay, so what actually is it? What actually does this mean? Well, it's actually the gradients. Okay, these derivatives, they're the gradient function, or they give the rate of change. Yeah, that's what they are for a quick refresher. So over here, in this region here, from all the way up here, all the way down to our turning point, you can see that we've got a negative gradient. It's different at different points, but it's always negative in this region. So over here is f dash of x is negative, it's below 0. Now over here on the right hand side, you see that we've got a different gradient depending on what x is, but it's always positive. So over on this side we've got our derivative, our gradient is larger than 0, it's positive. For this whole side from all of these numbers. And it's negative for all of these ones. Okay, but what is it right here at our turning point? Well, of course, if it goes from negative to positive, it must be 0. And you can see that because the tangent line is going directly across, okay, with a gradient of 0. So this is our first thing that we really need to note down, is that at any turning point, doesn't matter if it's a maximum or a minimum, or even if it's a point of inflection, which is one of these, anywhere that's a stationary point, which means it'll have 0 gradient. So at any turning point, or point of inflection, or so that's or, I'm just going to write stationary point, or other, it really should be or other, stationary point, the gradient is 0. Okay, gradient 0. In other words, our derivative function f dash of x equals 0. or using the other notation, dy dx equals 0. Okay, so let's now think about this example using our function that we've got to figure out what that stationary point over here actually is. So first, of course, let me just write this function down again. F of x is x squared minus x minus 2. Alright, let's figure out what the derivative function is. S dash of x is 2x minus 1. Okay, so we want that, to find this point, we want that to equal 0. So now we just have to solve this. So we've got 2x, we'll add 1 to both sides, giving 2x equals 1. Then we'll divide both sides by 2, giving x equals a half. Okay, so this point here must be here at x equals a half. So we're halfway there, but to find this point, we need two things. We need the x coordinate and also the y coordinate. So we've got the x coordinate, now we need to find the y coordinate by putting this value back in to our original function. So we're doing the function of a half to find the y coordinate, which is a half squared, take away a half, minus 2, which is 1/2 times a half is a quarter, take away a half, minus 2. Now we'll put it over a common denominator, 8/4. 1, take away 2, that's minus 1, take away another 8 is minus 9/4. There we go, it's not a straightforward result. So that is our y coordinate. So writing out our point, so we can write our turning point. Turning point is the point a half and minus 9/4. And if you look at our graph, hopefully that agrees. Yes, minus 9/4 is just a little bit less than 2, and that looks like a half. So yes, we have found it. We have found the turning point. Okay, so quickly to recap, for any turning point, any maximum point, or any minimum point, or any point of inflection, what you want to do is set the derivative to 0, and figure out what x is for that point. Then figure out what the y coordinate is by putting your x coordinate back into the original function. So we can of course do this on the CAS. Let me do it on the CAS really quickly. Let's get up a new page. Okay, so we're defining our function f(x) to be x squared minus x minus 2. There we go. So now what we want to do is we can do this in several ways. Let me do it in a few steps. Let's find the derivative of that using calculus. Find the derivative in terms of x of our function. There it is, it's 2x minus 1, just like we expected. And now we'll use the solve function. Algebra solve. Solve when 2x minus 1 is equal to 0. And we want to know what x is. There we go, x is minus a half. And so now we'll find our function of 1/2, 1/2. There we go, minus 9/4, just like we expected. So there we go, the whole thing is done for you there on the CAS. Or if you're wondering how to do it by hand, you might want to restart the video again. Okay, now of course, if you've got a case where you've got two turning points, so like a cubic, for example, so you've got something that looks a bit more like this, whoops, and there are two turning points, that means when you find your derivative, s dash of x, it's going to be, because our original function, f dash of x had an x cubed term in it, that means your derivative function is going to have an x squared in it somewhere, so plus some other stuff maybe, which will give you two answers for x. X equals something or something else. Two answers. One answer will give you this one answer will give you that one. So there you go, there's how you can find the maximum or the minimum point using calculus.